with our first session. I hope I'm recording. Yes, I'm recording. Okay. Okay. So we'll start off with our first lecture, and the thing is that if you get any doubt in between or any sort of thing, although this is a first session and this is going to be a pretty basic one, like we'll revamp everything that we have studied before in our 11th class, 12th, and in our bachelor's, whatever we studied, right? We're gonna repeat the same thing but in more detail, in more depth. Okay, so the thing is that our sessions are going to be more interactive one. If you get any doubt, you can type in chat box, or you can raise your hands and unmute yourself and you can ask it, right? Such that it'll be helpful for me, it'll be helpful for you, and I can see that we are in the same pace. Okay, so apart from that, you can find these lectures anytime in the meeting that we did. Like after, let's say you didn't understood one topic, so you can come back to the same meeting. Just you can open Microsoft Teams and access the meeting here. So this is the thing. Now let us start off with our lecture. Let me know if you didn't get anything, or if my camera has stopped or screen share has stopped. Okay, because I can't see myself or anything, I can only see the whiteboard screen. Okay, so the first lecture is going to be on linear algebra. As I said before, that this sessions is going to be in detail oriented session. This is not like the sessions which we are doing on YouTube. This is going to be in detail, uh, complete mathematical sessions. Okay, now why linear algebra? You might ask, like there are 100 things, right? There are lang chain, there are lang graph, or there are Python tools. New AI tools are coming up. So why do we have to start with linear algebra in the first place, and why is this only? If math is the foundation, then why linear algebra is the foundation, or you can say starting point of AI? The reason is that if we go back to, I don't want to go on history and everything, but if we go back to 19th 80s or 1990s, you will see that AI has started at that point, not in 2022 or 2023. Like scientists were working on machine learning algorithms and everything back in 1980s. And if you take Alan Turing machine and every other like computer big discoveries came through matrices. So matrices, understanding algebra, is the foundation, is the starting point of computer science, and we are studying AI, right? AI research part. So it's going to be the foundation, and I will show you like how it is important and why it is important, and you will be shocked, like do we actually use this concept in this application? It's gonna be crazy, it's gonna be really interesting. Okay, so let us start off with our lecture, and let us start with the first thing, which is what is linear algebra. Okay, so I'll make things small here because we are going to write a lot of stuff, but for now, let's keep it okay, medium. So what is linear algebra? Okay, so we have studied about geometry. I might write spelling mistakes, so forgive me. But we have studied in 11th class, we have studied a concept called as coordinate system, or system of coordinates, where a scientist or mathematician pointed out the smallest distance between 2 points. After that, we have studied about circles, ellipses, and all this sort of things. So we know how we can draw uh, lines, or how we can draw diagrams, or how we can draw geometrical structures in mathematics. We have learned that in our computer science. Okay, now the thing is, I hope I'm doing side by side. Just give me 1 minute. uh, just give me 1 minute, sorry. Yeah, see, I'm not recording my camera. Okay, let it be. So if you see the concept of geometry, we know how to visualize like circles, we know how to visualize ellipses. Okay, now this is geometry part, and along with it we have equations part of that as well. Like we studied polynomials, right? In polynomials we have studied different types of equations, like linear equations, quadratic equations, cubic equations, and everything. But coming back to the definition of linear algebra, the definition of algebra, or you can say the core uh, the core goal of linear algebra is to find solution for a given set of linear equations. This is the main goal that we have invented linear algebra. What do I mean by this? Let's say I have equations like I can take example like I'm taking any random example, not particular one. Let's say I have equation 2x minus y is equals to 0. Okay, let's say this is our equation 1. Now I have another equation x minus 4y is equals to 3. I'm taking equations where we have x and y. We can have 3 variables, we can have 4 variables, we can have n number of variables, it doesn't matter. But the thing is, for a given system of linear equations, finding solutions is nothing but linear algebra. Okay, this is the main goal. Why do this is the main goal why we have built matrices. This is the main goal of linear algebra, to find solutions of a system of equations. I hope we are clear till now. So here we have a equation 2x minus y is equals to 0 and 4x minus y is equals to 3. So this is equation 1, equation 2. Now this equation is a very interesting part. I'll tell you why, I'll tell you how. And this equation is a very like natural, oh god, screen share has stopped. Okay, this equation is a very uniform and good equation because it has two equations and there are two variables, two unknown variables. And in some cases, we will get equations where we'll have 3 variables and 2 equations, or vice versa. For example, we might have a case where we will have 3 equations, and in that there will be no uniformity. For example, we will be having x in one part, in second equation z, in third equation y. So here there's a non-uniformity there. So it is going to be a like different case. But if you take this example, how can we see this equation? So in linear algebra, we see any given system of equations in 3 ways. And what are these 3 ways? These 3 ways are, first one is row picture, and you can find this exact line by line things told by Gilbert Stand in his book. So the first picture is row picture. I'll talk about like what is row picture, what is column picture and everything. But the second picture is column picture, and I'm gonna put a mark here, important or star mark, because this is going to be important. This understanding of column picture is going to be really important when we talk about large language models. And third view should be matrix view. Okay, so these are the 3 pictures through which we can understand what is this equation and how we can find solutions for these equations. Okay, so let us start off with row picture. So here in row picture, we have a line, right? So the first equation is 2x minus y is equals to 0, and the next line is x minus 4y is equals to 3. Okay, got it. Now observe the first line, observe the not first line, first equation. So if you see the first equation, is representing a line. How is it? So let me draw here axes. So let's say this is our y-axis, this is our x-axis. Okay, forgive me if I'm drawing like very bad diagrams and bad like things here, but let us assume that this is our x-axis and y-axis. And if you draw the picture of the first equation, we can write here that 2x is equals to y. And from this equation, you can, okay, let's find the solution for first equation. So here this is our origin point, right? So I'll just draw here, I'll take pencil. So this is our origin point. Okay, 0 comma 0. So 0, understand this, tell me that whether the first point, right, 0 comma 0 for the first equation, whether the origin will be a solution. You can comment yes or no, or you can tell like yes or no, right? So
Yeah.
tell me, it is a solution. Okay. Now, what are the other solutions? Can we find another point? Let's find, let's say y is equals to, or x is equals to 1. So let's say this is 1. So this is 1. Now, if x is equals to 1, then what is the point of y? 2. So here, let's say this is 2. So if you meet these 2 points, let me change the color of the point. So here, this is going to be our point. And if you draw a line through this both points, you will get the solution of that line. So let me draw a point which passes these two lines. Oh God, really? Okay. Okay. So I'm drawing like very bad drawing, forgive me. But this is one line. Okay. So let me draw a line, not arrow. Okay. So can I say that, okay, this point, you can see this is the line for 2x minus y is equals to 0. This is the line for this given equation. Okay, now second equation. Let's see second equation. Can I write x is equals to 3 plus 4y? Okay, now tell me whether this particular second equation passes through origin.
Yes.
Is it? Is it? Tell me, like tell me, let's say let us assume that
No, 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 it will not pass.
yeah, let's assume that if y is 0, here I'm writing, if y is equals to 0, then what is the value of x? X is
3.
going to be 3. So here, let's say, again I'm drawing, let's say 1 2 3, this is 3. So this is 1 point. This is like first point of the second equation. Now let us see that what if y is 1? What if y is 1, or if y is equals to 0, then x is 3. Now what if y is 0? No, what if x is 0? If x is 0, then we'll get, if
Minus.
x is 0,
Okay.
then minus 3 by 4. Let's not go to that point, because again we'll get decimals, so let's not go to that point. Let's fix it through decimals only. Okay, not decimals, integers only. So if y is 1, if y is 1, here I'm writing, um, okay, so here let's say I'm writing, if y is 1, then our x is going to be x is equals
7.
to 7. So if I draw this point, let's see, this point might be somewhere before that. Let's zoom it out. Yeah, I'll just zoom it. Let me take this and, okay, thoda sa, right? It's all right. It's all right. Now, here, let's say this is 7. So if y is 1, this point is going to be a really bad point, but what we can do? Okay, this is our point. This is the point. Now, if you draw a line, passing these 2 points, okay, this point and this point, I'll put it up little. Okay, little up, not okay, this is going to be bad, but yeah, you can see this is first line, and this is the equation, right? This is the equation of x minus 4y is equals to 3. Okay, so this is now tell me what is the common solution for both. The common solution for both is going to be this point.
Hmm.
Is it correct?
Yeah.
Correct till now? Correct. I hope you have understood. So this is known as, like in row picture, what we do is that we take system of equations, we draw the lines, we draw the planes, whatever we get, and whatever the intersection or commonality point where we are getting a solution, where we are getting both variables, both unknowns are satisfying, then it is the solution, it is the answer for the given system of equations. So this is row picture.
Okay.
Okay, okay, Jabir, we have understood row picture. Now tell me column picture. Column picture is the most important one. So in column picture, what we do is that, let me draw black ink again. Okay, so in column picture, we take variables, we take the equations. So here, our equations are 2x minus y is equals to 0. After that, x minus 4y is equals to 3. Okay, got it. Now, I want you to see the given equations in the form of vectors. Okay, so how many unknowns are there?
2.
2. Okay, and how many vectors will there be? So if I
2.
draw this system
1.
of equations in the form of vectors, then it will be something like this. 1. After that, let's not use it. Let's use our pen. Okay, so 1 second, not this. X minus what happened? Okay, so x minus 4y is equals to 3. Now, let's try to visualize the given like equations in the form of column picture. So I'll write 2 and 1. Okay, and let me draw bracket here. I'll put a bracket and I'll increase the size of this bracket. Okay, थोड़ा सा size बड़ा कीजिए. Okay, can we increase? Okay, yeah, we can increase. So I'm trying to cope up with this thing. Like, it's gonna be a little slow, forgive me, but थोड़ा सा copy paste करके once I buy Pentab, it's gonna be really like easy for drawing and all. But for now, just cope up. So let's say this is our first vector, and I'm multiplying with that vector. Let me write it with x. Okay, so I'm multiplying vector 2 cross 1 with a scalar value plus I can write 1, actually minus 1 comma minus 4y, right? Okay. Like, just interrupt me if you have any sort of doubts. Now again, I'll copy this brackets and paste it and take it here. So minus 1 comma minus 4, and this left bracket, copy and paste, copy and paste and take it here. Okay, and I'm multiplying this vector with again a number, and I don't know what number is that number is, but I'm multiplying it with y, and what I'm getting as a result is that again a vector which has 0 and 3. Okay, so here what we are doing is that we are taking a set of linear combinations. So let me take this plus. Okay, just not this one, but you can see, right? 2 1 multiplied by x plus minus 1 4 multiplied by 4 is giving 0 comma 3. Okay, now let me show you in the form of diagram as well. Okay, so here I'm going to draw the vectors. Okay, so this is our x plane, and this is our sorry x plane, and this is our y plane. Now if you take the first vector, let's say this is one vector. So in this vector, 2i and 1j, so this is going to be 2 of x and y of 1. So this vector will be somewhere here. So 2y and 1j, this is our vector 1. Okay, this is our vector 1. Now, another vector is in minus 1 and 4. So here, minus 1 and minus 4. So x minus 1 and y minus 4. Okay. So this is our vector 2. Got it. So we have plotted our vectors. Now, what we are doing is that we are multiplying vector 1 with some number, and we are adding and before that, like in this equation, in this, if you see this equation, what we are doing is that we are taking vector 1 multiplying with a scalar, putting that aside, and again vector 2 multiplying with another scalar, putting that again. And what we want is that when we add these two vectors, we should get this answer. Okay, again screen has stopped. I need to really like see some storage spaces, and also like see pen tabs as well, because I lost my pen. Okay, so this is the thing. Now if you see, the resultant should be the value of x and y. Like if I'm combining this, then I should get this vector 0, 3. Okay, let me draw the b value. Let's say this is a, okay, and this is b, and this is c. I'm just giving some random numbers. Okay, now I'm multiplying a with some vector. So when I multiply a vector with a particular scalar, then its value will increase, and after that again vector 2 with some value y. Now when I'm multiplying and adding, we'll get a resultant vector, and that resultant c should be something like that. So let me draw this exactly from, sorry, okay, here, from origin to y3. So this is how our vector should be. This is our c. Okay, now I hope you have understood. And in this, what we do in column picture, what we actually do is that we put values like let's say we put 1, x has 1, y has 1, and see whether we are getting result or not. And again we'll put, like, if it is not matching, sorry, again what applications I'm running, let me close all applications. I'm only running 2 applications. One is Chrome browser and another one is Teams. Okay, so let me. Okay, so what we do is that I'll come repeat my statement again. So we have vector 1, we have vector 2. We put different values and we try again and again to get the resultant. And you know what? In MATLAB, the things we do, like let's say you're finding solution for a given system of equations and you have put 3-4 different vectors. Okay, not 3-4 different vectors, 3-4 different equations, because in MATLAB we do that. So when we put different equations, what happens is that MATLAB does the same operations which I'm doing. In MATLAB, the code puts different linear combinations to find solutions. So I hope you are clear. Do you understand what we did in column picture? In column picture, we take different values of x and y, we try to put it there, and we find solutions. Clear?
Mm.
Okay. Any doubts till now? It seems your silence is showing that you
Like,
have having.
wait,
Hmm.
how, like, how did we find the solution?
In column picture.
Yeah, like, how did we get the solution?
Okay. So in column picture, what we do is that we take different values, and this is a trial and error method. Like we know that if the vectors is lying in the real numbers plane, okay, then the answer is going to be in real number plane, until unless there is no condition for parallel vectors. Again, this is going to be in a different territory, but let's not confuse you. So in column picture, how we find solution is that we put different values. Like for example, what is the common solution we got here? Let's find the common solution in row picture first. Okay, so here if you see this point, what is this point? Let me find the solution. So here our y is equals to 2x. So here let me substitute it back. So x minus 4y, right? So 4 into 2x, so it will give me to 4 into 2x, right?
Minus 8.
Minus 8 plus x will be 7.
Minus 7.
So minus 7 x is equals to 3, so x is going to be 3 by 7. So something like this is a bad equation, that's why I'm getting a fraction, but I'll get a fraction number. Okay, and I'll take that value, I'll put it in here, x value, which is minus 3 by 7. So y will be minus 6 by 7. Okay, so we got x, we got y. Now we will, in column picture, we put every other number. In MATLAB takes the equation, MATLAB keeps on putting the equation. In MATLAB, what happens is that we create these vectors, okay, and we put the variables aside, okay, beside it, and we take value 0, 0.1, 0.2, 0.3, something like that. MATLAB will keep on doing, and whichever combination matches, that will become a solution.
Okay.
So in linear column as well, we take linear combinations. We put different values. For example, here we know that x is equals to 3 by 7, actually minus 3 by 7, and y is 6 by 7. So y is equals to minus 6 by 7. So if you put this combination in this picture, then you will get C vector. Are you getting me? So this combination of x and y will be a solution. Like this, MATLAB will put different things to find all the combination for the given system of equations.
Okay.
Any doubts?
No.
Okay. So this is the thing. Now in matrix, what we do is we imagine the we imagine every system of equations in the form of this way: ax is equals to small b. So what we do is that we first of all put every number we have in matrix, like 2 minus 1, after that 1 minus 4. Okay, and we multiply this matrix with unknowns. Which are the unknowns? Unknowns is x comma y. So we'll take x and we'll take y. Okay, when we multiply this both matrices, I can't draw square brackets here.
It's
That is
okay.
why.
I can understand.
Okay, so here is equals to, and here this is the answer we should get, 0 and 3. Okay, now how are we gonna, like, we have represented our matrix in this form, but how are we going to find the solution for this thing? To find solution, we do a different method. We follow a different method, which I will talk in few minutes. Okay, if you give me time, I will talk about this method. The method name is Gauss-Jordan method or Gauss elimination method. First we'll study Gauss elimination, and moving on we'll see different methods and why they are important, we'll see. Okay, but this method here we eliminate, and this elimination step is found by Gauss. Okay, we will see this particular path, this particular thing in few minutes, but let's put it in a square bracket and let's focus on this two. So I have told you row picture, I have told you column picture, and I have told you about matrix picture. How we see different uh, ways. These are the different ways of looking a given equation. So this is how we look at, like we generally see a equation and we think, oh, it's easy, but there are different ways of looking at it. You can see here I have visualized my given equation in the form of geometry, in the form of lines. Here I have imagined our vector in the form of vectors. Okay, I have like imagined our equations in the form of matrices. Okay, now which one is good? This is the question. And as I told you, this particular method is going to be way more important, and you will understand why this is going to be way more important, and why we actually, like, we can use these three methods to find solution, and you can program these three methods, but among these three programs the second method is going to be very beneficial, very efficient when compared to all three. Okay, and why is that? Why exactly is this second method more beneficial? Because it reduces the number of computations that a machine has to perform. Remember this, I'll explain in future when we complete 3-4 modules, not 3-4 modules, but in math only, in foundations of AI only. When we spend 2-3 hours or 4 hours, then I'll explain you why this is. And moving forward, moving in our like next lectures of linear algebra, we will see only this part. Okay, and after completing this, we'll come to second part. Okay, now the worst, or at least the least efficient way, and the first, like when we started imagining linear equations in 16th century, we started with this row picture because it is easy to understand. But as you move complexity, like here you have two equations, right? Two equations, two variables. Now, let me tell you why row picture is bad and why column picture is really efficient. Okay, so
Okay.
here, let's say I have an equation 2x minus y plus 3 z is equals to 0. Okay, now let's take some random values, and I have to make sure that these equations are good, because once equations are basically, if you see vector forms, in vector forms this equation represents a 3D plane or a plane, right?
Mm.
Now, okay, again screen has stopped. Okay, now the thing is that you cannot have solutions for a given system of equations if the lines are parallel or if the planes are parallel. So whatever the equations you're writing, those equations are considered good equations if they are not parallel, if they are intersecting at some point. So make sure that we are not creating a case where they are parallel. If in that case, nothing will work. MATLAB will not work, your approach will not work, and all. So I'm taking some good equations. Actually, I have examples here in my book. uh, no, I don't have examples. Let's take like y minus y plus z plus z is equals to 3, and after that minus x plus 2y is equals to 1. Okay, we have taken three different equations. Now, what does row picture tells us? Row pictures tells us कि you draw coordinates, and after that whatever the figure you have, you draw lines for all the given equations, or whatever the figure it represents, draw it, and whatever the intersection, common intersection point you find, that is your solution. That is what row picture tells. So let's try doing that. Okay, so here I'll draw my x-axis, I'll draw my y-axis. Okay, and this requires a bit of your imagination. Okay, this is my z-axis. Okay, so I am not exactly sure that what this plane 1, plane 2, and plane 3 represents. Like what are these planes? So let's see, let's take plane 1. Okay, the equation is 2x minus y plus 3z is equals to 0. 3z is equals to 0. So do you think that if x comma y comma 3 are 0, then is it satisfying the plane? It is satisfying the plane, right?
Mm.
Okay, so okay, so this is one solution. Okay, now if I take y value 2, okay, y value 2, I have taken y value as let's say 2. Okay, so this is 2. uh, okay, x value 1, x value 1, and again z value as 0, right? So here I have taken the first point as, let me write it. So I have taken the first point as 0 comma 0 comma 0. It is satisfying. 0 comma 0 comma 0, 0 comma 0. Okay, this is first point. And if I take x as 1, y as 2, and z as 0, okay, this is also getting satisfied, right?
Mm.
So what is the plane? So the common point would be, let's take a plane here. So the common point would be this point. The plane which goes through this two will be this. Like this plane has to go through origin and this point as well. So let me draw how I can do that. Okay, it should pass through origin. So you can see this is passing through origin, and this is passing through the given point as well. So this is the plane. The plane would be something like this. You can't see me. So the plane would be something like this. This is my plane 1. Very hard to imagine. Okay. Now, if you take second plane would be uh, see. So minus y plus c minus 3 is equals to 0, right? So here, let me write it. Minus y plus c minus 3 is equals to 0. Okay, so if I take y as 0 uh, and z as 3, so z as 3, so x, y, z, right? So z as 3, let me draw this point, z as 3 here.
Uh, like it has. Oh, nothing.
Tell
Nothing.
plus c is minus 3 is equals to 0. Okay, so let me draw this particular point here. So if I draw this point here, so this is going to be 3. So and if I take y as minus 3 and z as 0, then the point will again satisfy. So my another point would be somewhere here. So the thing is, this plane will lie only in uh, this x comma y, sorry, y comma z. It will not lie in z axis, x axis, right?
Hmm.
Okay, so this is my plane 2. Very hard to imagine, I know that. And can I write this third equation as uh, minus x plus 2y minus 1 is equals to 0? Okay, now if you take uh, y as minus 1, y as 0 and x as minus 1. So again, like this plane will lie only in x and y. I'm just drawing some random plane. It is taking much time, but let's say I'm drawing this only here. Okay, now the intersection point of the three planes. Okay, the
Hmm.
intersection point of plane 1, plane 2, plane 3 is going to be the solution of the given set of equations, right?
Hmm.
Okay, now here's the thing. Here's the thing you need to understand that uh, we can imagine one dimension, we can imagine two dimension, we can imagine three dimension. Now let us assume that there are 9 dimensions. Then can you imagine row picture? Can you imagine 11 dimensional, or let's say there are 11 unknown variables, 11 equations, and can you draw the row picture for these 11 equations?
Hmm. Don't think so.
Because when variables are increasing, dimensions are increasing, and for human brain it is hard to visualize or to imagine a 11 dimensional picture, right?
Hmm.
So that is why row picture is a very basic and very inefficient way of looking at this. And what is column picture does here? Column picture, you can write simply, these are the three equations, right? So write 1 minus 1, sorry, 0, x is 0 here. See these equations, right? X is 0 here. So 0, and again screen has stopped. Okay, so okay, so 1, sorry, 2, right? So here 2,
2 0.
0 minus 1 multiplied by x. So here I'm just writing x, okay, plus, give some space, plus again here let me write minus 1, right? Minus 1 and 2 multiplied by y plus uh, which one is it?
3
3, 1 and 0. Okay, what is the answer we are expecting? We are expecting is equals to, and I'm writing 0, 3 and 1. And what we have to do here, you just have to put here, I didn't wrote z, okay, z. So I hope you can able to visualize, like you just have to put numbers here, and it's just a probability game. Computers are very good at putting numbers and doing fast calculation rather than imagining this.
Hmm.
That is why column picture is the most important one. And for humans, which one is good? Matrix is good. You take n variables and you can solve easily by just writing. You can solve with hand, but combinations, like predicting combinations and visualizing diagrams are really hard for human brains. That's why we follow matrix picture.
Okay.
Okay, so till here understood, like what is linear algebra, how we see given system of equations, and why some are inefficient and some are efficient.
Mm.
Okay, shall we continue to next topic where we
Mm.
discuss about elimination and all that?
Yeah.
Or do you want to wait or take rest?
No, no, no. Let's go.
Okay, ठीक है, sure. We will try to cover two more topics, and this two more topics I'll try to cover as fast as possible. Okay, and for that, the next topic is going to be on matrix. Like we have discussed both topics, like picture view, row, column view, and row view in detail, but we haven't seen matrix visualization. So let's see how that works. Okay, so matrix picture. In matrix picture, specifically talking about uh, elimination. And which elimination? Gauss elimination. Gauss elimination and back propagation. This is the topic, second topic. Okay. Now, let's take a equation. I don't, the reason why I'm thinking wherever I'm taking equations is because sometimes we get parallel equations, we get parallel planes. So we never want to get like that particular thing. I'll tell you how we'll solve parallel thing as well, but so till now we have seen different things, and we started our lecture by understanding what is the core principle, what is the core meaning of linear algebra, and how we can visualize given set of equations. And in that we have talked about three different pictures. Okay, and among these three different pictures, we have talked about in detail row picture and column picture. Now what we will do in this again session now is that we will see the matrix picture. Okay, so in matrix picture we will take a equation, and what we will do is that we'll take that equation, we'll see how we can find the solution of the given set of equations through this matrix picture. And this matrix picture is in mathematics, in mathematical language, we call it as Gauss-Jordan elimination. Okay, and we will see Gauss-Jordan elimination, and I have written wrong here, background not, it is back propagation. Propagation. Okay, we will see like what is back propagation and all that. But before that, the goal of this Gauss-Jordan elimination or solving matrices is to find the set like given set of equations. Okay, now I have taken an example actually just now because we don't want, as I said you right, I'll explain you in detail in few minutes key what exactly parallel planes means and how we can visualize parallel planes in matrix forms. Okay, how we can tell that plane has become parallel, I'll tell you, but let us take an example for now, that x plus let me put this computer and books correctly. Okay, so x plus 2y plus z. I have just taken example from internet, so I don't know the actual solutions as well. And 3x plus 8y plus z is equals to 12, and then 4y plus z is equals to 2. So we have taken three equations and it has three unknown values, three different values, and our task of this lecture is to understand how this matrix picture work and how we can find solutions for the given set of equations. Okay, so as I said you that we represent every matrix in the form of ax is equals to b. So what we will do is that we write the given set of equations in matrix format, that is one. After that first let's write x ones. So 1, 3, 4, and again here we'll have space 2.
130.
Oh, 1. Oh, yeah, yeah. Sorry, my bad. So 130, and then okay, this is the problem with without pen. Okay, so 130, 2, 8, and 4, 2, 8, and 4, and then we have let me write it properly. 1, and then 1, right? 1. Yep. And here also 1, 1, 1, 1. Is it 1, 1, 1? Yep, it is 1, 1, 1. Okay. Now here let me take this is not as equals to this is plus actually. So yeah, these are my equations. Now we have to multiply this matrix with a given set of variables. Let's say x, and then y, and then z. Three unknown variables. We are multiplying three unknowns with the given matrix, and the answer we should get is 2, 12, and 2. Okay, got it. So we have understood the representation of how we are going to represent our given set of equations in matrix format. Okay, got it. Now the thing is that to find the solutions of this xyz, what we will do is that we in Gauss-Jordan method, like Gauss-Jordan does very basic thing, like he takes first equation and take the value of x, put that in second equation, take the value of y, put that in the last equation, and when you put all the values of x, y in the last equation, then you will end up with one variable, and you can easily calculate the variable z. And yeah, after finding the value of z, you put it back, you find the value of y, you put it back, you will find the value of x. I'll show you very easily. And like Gauss Jordan, I don't think so like he did some miraculous thing or a out of the world thing. If you were born in that time, then you would have done the same thing. So here what we will do is that we will take our matrix 1, 3. You know what, let me copy this entire thing now. Copy, paste, take it here, remove it, we don't need this time. Okay, after that I'll take this 1, 1, 1. Okay, copy and again paste, take 1, 1, 1 here. Okay, so we have this matrix. Now what we will do is that uh, we will take this one as well, this and this, copy, paste it here. Okay, now the goal is that, let me zoom it, so we have to zoom it now. So the goal is that we have this matrix, right? We will perform some operations on this matrix. Okay, and the goal is to take, or instead of telling, let me just show you, right? So here we take this first element as a first pivot. Okay, and whatever the elements which are under pivot, the goal is that to make them 0. Okay, so what we will do is that we will take, you can see under it we have row 2, we have row 3. So under 1, the problem is that key row 2 is non-zero, right? Under 1, which is our pivot element, the element is non-zero. If it is non-zero, then Gauss-Jordan tells that not Gauss-Jordan, Gauss, that you have to make it to 0, because no element under pivot should be 0. Okay, so what we will do is that what we have to do, like to remove 3, we will take row 2 and we will perform some operations on row 2. What operations? Row 2 minus, can I do 3 row 1?
Yeah.
Okay, when we do that, what happens? Just observe this. So here the second row, in second row, let me write the second row. So first row will remain same, 1, 2, 1. Okay, now under it what happens is that 1 3 minus 3 into 1, which will be 0. So here we'll get 0. Now the next element would be 8 minus 3 into 2. So 3 2 just 6 minus 8. So 8 minus 6, which will be 2. Okay. Now let me know like if I'm doing any wrong calculation. Now thus here the element is 1. 1 minus 3 into 1, which will be 1 minus 3 minus 2. Good? Are we good?
Yeah.
Okay. Now the underneath elements will remain the same, 1, 4 and 1. And along with it, like here you might ask, like if you are, I hope you have studied everything in school,
Mm-mm.
but the thing is, you might ask like, Jabir, why did you take this? Like you have taken this and put this thing here, why did you do that? So we call this thing as augmented matrix. So this entire thing we call it as augmented matrix. But for now, just imagine that there is no this. Okay, there is nothing like this. Okay, we haven't taken. Now the rule is that key, whatever operations you are performing here, you should perform here as well,
Mm.
to maintain balance on both sides.
Mm.
Okay, we will see what is augmented matrix, why do we even need it. So the thing is that when you take RHS, which is the right hand side result, and put it with your A matrix, basically putting okay, let me write here. So basically writing A augmented B. So here this is known as a augmented matrix. Basically you're writing complete A matrix, you're writing a straight line and writing B. So this format, this representation is known as a augmented matrix, and we will talk about why augmented matrix, why do we need it and all that, but give me a few minutes. So here I will perform operations later on, like for this matrix, right? Okay, let me write it here. For this matrix, I'll perform at the end, like whatever perform like, operations we're performing, right? I'll at the end I will like calculate all the operations and maintain it both. Okay, both RHS and LHS. Okay, now we got this matrix. Okay, now here uh, which is the pivot. Now what happens is that if in the first pivot every element is 0, then change the pivot. So we will change the pivot to the next row, next element. Okay, so this will be our pivot, next pivot. So this is first pivot, second pivot and third pivot will be this. And we keep on doing that until unless we move diagonally. Okay, and when we move diagonally, what we should make sure is that whatever the elements which is coming under this diagonal should be 0.
Mm.
Okay, now you can see in this case our pivot is 2, and underneath it there is one element. So
Mm.
what we can do, we have to make it to 0. So can I for row 3, can I perform this operation, that row 3 minus 2 row 2?
Mm.
If I do that, will this 4 become 0?
Yeah.
Okay, so what I'll do is that I'll write the element 1, 2, 1. After that 0, 2, this row 1, row 2 remains same, so minus 2. And then okay, now 0, like row 3 is 0, minus 2 0, which will be 0. And now row 3 is 4, 4 minus 2 into row 2's element, which is 2 here. So this one, so 4 minus 4, which will be 0. And here minus 2, 1 1 here, 1 minus 2 into minus 2, this will give me
Right.
5, right?
Mm.
5. Now which is the pivot now? So we will get a third pivot, which is this, and under this element there is nothing, there is no elements under it, so we will stop here. Now we will calculate the RHS as well now. Okay, now you might ask like, Jabir, like first of all you have completed LHS and then you are going to complete RHS now. Like let me show you this. So uh, if I do, if this is the pivot, so row 2 minus row 1, right? So here this will remain 2. Now what happens is 12, right? 12 minus 3 into 2, so 12 minus 6, which will be 6, and this will be 2. Now again in the third operation, my RHS side would be 2, 6, and what I'm doing, row 3, which is this element, 2 minus 2 into 6, 2 into 6, which is row 2, right? So like 2 minus 2 into 6, which will be minus 12 plus 2. What is that?
-10.
Minus 10. So why I did separately is because again, this is related to MATLAB. MATLAB does the same thing.
Okay.
So when we are performing Python code, right? Python code generates the first LHS and then RHS. Humans does the both thing. So assume that I am MATLAB, right? So here you can see now here if you take the original form, which is a x is equals to b, in this case here z will be there. Okay, so can I write phi z is equals to minus 10?
Yeah.
Okay, and from this step can I write z is equals to minus 2?
Yeah.
Okay, so we got the z value. Okay, and what is this equation? What is this equation? This equation represents like 0x
2y plus 2y minus
0x plus 2y minus 2z. 2z is equals to 6. Now we know the value of z. So 2y minus 2 into minus 2 is equals to 6. So can I write 2y plus 4? Plus 4, if it goes there, then it will become minus 4. 6 minus 4 will be 2. So is equals to 2 and y would be 1.
1.
So this is the thing. Okay, so here we got the second value as well. Okay, now I'll put this y value, z value in 1. So I can write x plus 2y plus 1 is equals to 2. Here z. Okay, 2. Now x plus, we know the value of y and z. So 2 into 1 plus actually minus 2 is equals to 2. Now you can write this 2 will get cancelled. Now we'll get the x value as x is equals to 2. So you can see we got the values of x, y, and z. And if you observe what we did, first we eliminated. Okay, we have eliminated our matrix.
Yeah.
Okay, and the goal is to make our matrix into a upper triangular matrix. So if you see here, the matrix which we got at the bottom, okay, is a upper triangular matrix. Okay, so the Gauss elimination says that step 1, take your matrix, take A, and keep on doing, like along with it, keep your eye on RHS as well. Okay, now after taking it, keep on going and perform, like keep on doing your row operations until unless you get upper triangular matrix. Now once you get upper triangular matrix, what you will do is that take your vector xyz, right, start multiplying it. So when you multiply xyz with this upper triangular matrix, then you will get the values of z, and when you get the value of z, put it back, and this putting it back is known as back propagation.
Okay.
Okay, so put it back, you will get the value of y, put it back, you will get the value of z. This method is known as uh, Gauss elimination. Okay, now we have taken it. There are few things which you need to understand, that they are good equations, they are bad equations, and good equations gives us the solution. They are very good. Like this is a very good basic. I have searched it on internet, and whatever I found, I have wrote that equation because this is a good equation. I don't want bad equation. What I mean by bad equation? Tell
I
what I
don't
mean by
know.
bad equation. And
Bad equation doesn't have a solution.
correct. So bad equation don't have solution. And uh, again, like if I have to, let's go back to our picture, right? Let's go back to our three pictures, right? So can I say that these three equations, okay, these
Mm.
three equations represents a plane?
Yeah.
Okay. Now, if these three equations represents a plane, then there should be some conditions if you want a common solution for these three planes.
Yeah.
Okay, I'm explaining the three pictures as well. Like what is the meaning of bad equation with respect to three pictures. So when you take a plane, let's say this is the first equation plane, this is second equation plane. They both are intersecting at some point. Now imagine that my third plane is like this. Now
Mm.
tell me, like for this three planes, which is the common intersection point? Zero common intersection point because parallelity is there.
Mm.
That is why it is a bad equation. Okay, so if you can tell the equation is bad if the slope between two equations is same, or if both of them both of this equation are parallel. And again you can do your geometry and find out whether the planes or lines are parallel or perpendicular to each other. You can do that. We have mathematical stuff for that. Okay, this is first picture. Now second picture. In second picture, how can we imagine? So in second picture, what exactly are we doing? We are taking vectors. So if you remember dot product, right? We have
Mm.
cross product and dot product, right? We
Mm.
make sure that vectors should not be perpendicular, because when we do when you do dot product, when vectors are like perpendicular or parallel, if you get any sort of this condition, then your vectors become bad vectors because you can't do product.
Mm-hmm.
And when vectors are parallel, right? When vectors are parallel, there's no commonality, there's no common solution in that case as well. And
Mm.
so this is how we tell in vectors, when vectors are parallel or
Mm.
perpendicular, then those equations become bad equations.
Hello. తెలీదు. నేను చదువుకుంటున్నా. Go on.
Yeah,
Hello.
yeah. So in that case also, like we get bad equations. Now how can we imagine that from vector representation? How can we tell that a given equation is a bad equation from vectors? We
Mm.
can tell through few methodologies. For example, right, here I have taken pivot 1, right?
Mm.
The first element is the pivot. Now imagine first element is 0.
Mm.
So the goal, if you see in matrices, in Gaussian elimination, what we are doing, we are taking first element and we are like the goal is to make all the elements 0 by doing some row operations, adding it, multiplying it. Now if you have the first element 0, like no matter what you do, like whether you subtract second row from first row or third row, whatever you do, the first element is 0 and no amount of subtraction or addition will never change it to the next element 0, because this is 0.
Mm.
Are you getting me?
Yeah, yeah.
Yeah. So in that case, what we will do, we will alter rows. This is a temporary failure condition. Like again in matrices, we have two things: permanent failure, uh, temporary failure. So if I get 0 here, I'll swap both rows and try to do something. Now if I can able to fix it, like by swapping, if I can able to fix pivots, then it is good. I'm happy. The equations are good equations. Okay. Now imagine that at the very last,
Mm.
right, at fifth element you got 0. And what is
Mm.
the rule? The rule is pivots should never be 0,
Oh,
and
yeah.
you got a 0.
Mm.
So and there's no rows under it, and you cannot change it as well, because once you change this third row with upper row, upper triangular matrix is not forming.
Yeah.
So if you get at the very bottom, and if there are no elements under it, if there is no chance of changing even after changing rows, like interchanging rows, you are not getting anything. Your like your pivot is becoming zero only. In that case, you tell that that is a permanent failure and the equations are bad.
Okay.
Got it?
Mm.
Okay. So this is how we do um, this is how we find solutions for matrices, linear equations through matrix method. Okay, now can we talk about mathematics? I know this is a practical class, but can we talk about some mathematical stuff?
Okay.
Okay, so what I'm doing here, I'm taking a, right, here, I'm taking a, let me write capital A, and I'm transforming that A by doing some row operations, eliminations and all that to a upper triangular matrix. Am I right or wrong?
Mm.
Okay, ठीक है. Now, let's talk about mathematical only, like mathematics, okay? So, the goal, we are very clear with our goal. Like the goal is to take A and to convert into, keep on doing operations until and unless you get the upper triangular matrix. And when you get upper triangular matrix, you will find X, Y, Z.
Mm-mm.
Okay. Now, let's observe this step. This step. Okay. So here, the matrix we had is 1, 2, 1, 3, 8, and 1. After that, 0, 4, and 1. Okay. So this is the matrix we had. Now, what we did here, can you tell me like what we did? We want this matrix. We have to eliminate the elements which are under first pivot. So our goal is to get 1, 1. After that, 0, uh, 2 and minus 2 here, and here 0, 4 and 1. Okay, so our goal is to eliminate the elements which is under uh, pivot element 1. Now, can you tell me that from which matrix, let's say this matrix, as we are eliminating, right, we are eliminating the elements which is under 1.
Mm.
Now let's say that the matrix is E. Now can you tell me a matrix E, if I multiply this matrix E with A, then I should get this output. How can you find this matrix? Tell. Can we find this matrix actually? That is the question.
We cannot use division in
What?
matrix. We can't use division in matrix.
We can't use division in matrix.
Can we?
No, 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 we can't. Okay. Now the question is, key, we can do multiplication, right? So my question is, key, you have this matrix and you want this matrix. Okay. And I'm telling that there is a matrix, there is a matrix E. When you multiply the matrix E with matrix A, you will get this.
Mm.
I'm telling you there is a matrix, but how can we find that? Now observe what I'm telling, like trying to tell. Please observe. Okay, so here I have A,
Yeah.
and if I multiply with I, what is I?
Identity matrix.
Identity matrix. If I multiply my matrix A with matrix I will get
Mm.
A, correct?
Mm.
Okay, now let's take an example. I wish I had whiteboard in my hands, but oh no, I don't have pen. But see, I want you to observe. So can I say that any matrix you take, multiply it with identity, you will get A?
Yeah.
Okay. Now, uh, Observe this. You need to like understand column picture as well. I'm going to column picture. I know like little confusing, but once I tell, like once we complete this mathematical expression, everything will be clear. Just believe me. Okay. So here I'm taking a matrix. This matrix has, let's say, few elements. Let me expand it. Let me expand this thing. Okay, I'm taking a matrix. Inside this matrix, I have few elements, and I have another matrix. Let's say this matrix is X, Y, and Z. Uh, this is actually a vector. Can I say this is a vector?
Yeah.
Okay. Now, let's say this is row 1, row 2, row 3, right? So when you multiply this matrix with a vector, the answer would be column row 1 times column 1. So we will multiply X cross entire matrix plus Y cross entire matrix plus Z cross entire matrix. If you have any doubts, take example and multiply it. So do it right away, like not now, after lecture, like you will have the recording of this class, so you will see how and what I'm trying to tell. So I have a matrix which has like it can be a square matrix, it can be any type of matrix, and I'm trying to multiply it with a vector. Okay, so I'll get X times the matrix plus Y times the matrix plus Z times the matrix. Okay, this is a, you can say, a sort of rule, like A cross I is equals to A, right? Like this is also a rule. Okay. Okay, now the goal is to find this E. Can I write? Let me write. So here I'm taking 1 0 0. So let me see what I have to do here. I am going to perform operation on row 2, right? Operation on row 2, and what operation I am performing? I'm subtracting. Tell me what I'm doing. I'm subtracting 3 times. I'm subtracting 3 times row 1 from row 2. Correct? Correct or not?
Yeah.
Okay. Now, I want you to really understand this. Okay. So now I'm writing minus 3 because I'm multiplying it with 3, minus subtracting 3, right? And 1 and 0. After that, I'm writing uh, 0 0 0 0 0 1 0 0 1. Now multiply this. Multiply this matrix with A. What is our A? Let me copy this. This is our A. Multiply. Multiply right now.
One second, actually. Can you tell me how did you get the previous matrix? One second.
What?
The previous matrix. Okay, you're
Which one? This
multiplying with
matrix?
identity
This
matrix.
matrix?
Okay. Yeah.
How I got this matrix? Okay. So what are we doing? We are taking 3 times of row 1 and putting that in row 2. Okay.
Yeah.
And what I said, if you take a vector and multiply it, then the vector multiplication will be like this. Okay. Now imagine this vector, which is minus 3 on row 2.
Okay.
Didn't get it? Did not get it, right?
Yeah, I got it.
Okay. So first of all, multiply this and tell me whether you are getting this or not.
Yeah.
Did you got it or not?
Like I got the first row correct.
First row correct. Second row,
Like, okay, I'll do.
you will definitely get it.
Okay.
Right? Try doing that. Now we got this output, right? We got this output. Now here's the thing. So we got the output. I'll put it here. Now tell me a matrix, let's say E2 or something E again, elimination, right? Such that we will get this one. Which one? This one. We should get this one. Tell me now, which is this matrix? So what I have to do? I have what I'm doing. Let me write the operation. So I'm doing. This might be a little confusing because once you have clear picture on column,
Mm.
right? When I say columns, columns basically taking a row and multiplying it vector. This
Mm.
will be like this. Okay.
Okay.
So I want you to sit and do a practice problem or do a sample thing, create a matrix and try to do it. You'll understand it. Okay. So how we can write this? I can write it as 1 0 0 and after that 0 1 0 and what operation I'm performing, on which row I'm performing, third row, right? This is
Mm.
the thing. So in third row, what I'm doing actually, I'm subtracting 2 from row 2. So I will write 0 minus 2 and 1.
Okay, now I got it.
You got it?
Yeah.
This is the thing. And we call this matrix and this matrix as elimination matrices.
Okay.
Okay. So here, can you tell me on which row I'm doing elimination?
It's third row. Okay.
On this, tell me.
On that,
Like
you're
this matrix, by saying this, what you will tell? Like on which matrix I have performed.
identity matrix. Yeah.
This is identity matrix only, but we have changed the number. The thing
Yeah.
is that we performed on row 2,
Yeah.
right? So can I write E2, I should write prefix now, E21. Can I call this matrix as E21? Because I'm performing operation on row 2 through row 1.
Again. Okay.
Okay. Now can I tell this matrix? Can I write this matrix as this particular matrix as E32?
Yeah.
Because I'm performing operation on row 3 through row 2.
Mm.
Okay. So if you take what I'm doing here, I'm taking matrix A, and I'm multiplying it with E21, and whatever the answer I'm getting,
Mm.
again I'm multiplying that matrix with E32.
Mm.
And if I do this operation, then I'm getting a upper triangular matrix.
Yeah.
This single line, okay, this single line represents all this.
Okay.
This is why I have emphasized so much on this particular thing. Like uh, it is hard to explain, but it is logical. If you see, once you do multiplication, you will understand. Oh, this is how it is happening. And I think few minutes only I will talk about multiplication. I'll talk about I have told you, right, how we can see a equation in 3 different ways. Like that, I will tell you how we can see a given matrix when you multiply in 3 different ways.
Okay.
Okay. I'll tell you, but this is the thing. This is the mathematical representation of Gauss Jordan, not Gauss Jordan, Gauss elimination.
Okay.
This is the equation. Understood? I hope you have understood how we do elimination. Any doubts till now?
No. No.
Okay, and we call this E matrix as elimination matrix. When you write A and B together, we call this as augmented matrix, and whatever the result you get here, right? Here. This is a upper triangular matrix.
Okay.
Okay, got it. Now, one more thing I want to mention. So we have talked two topics till now. One is how we perform manually uh, Gauss elimination. Okay,
Mm.
and we have talked about elimination matrices, how we can get elimination matrices for a given matrix.
Yeah.
Okay, now there is something called as permutation matrix.
Mm.
I hope we have discussed this previous as well. So two, let's say you have I, right, and in you have A, right. In A, let's say there are three rows: row 1, row 2, and row 3. Okay, now let's say because you get pivot in first row, pivot as 0 as first row, let's say you want to swap it with row 2. What you
Mm.
should do is that take I, we have to take a permutation matrix. So we know what is I. I is identity matrix, which is 1 0 1 0 0, and then 0 1 0, and then 0 0 0 0 1. Okay, this is
Mm.
our identity matrix. Now what we will do is to swap rows uh, 1 and 2, row 1 and 2 in A. We will take a permutation matrix, and that permutation matrix will be the swapped rows of the exact swap rows of I. So 0 1 0. I hope you are getting what
Yeah,
I'm
yeah,
telling,
yeah.
right? 0 0 1. So when you take this permutation matrix and multiply it with A, automatically your rows of A will be swapped. If you want to swap 1 and 2, then automatically it will get swapped. You just have to multiply it. So this is known as permutation matrix. And where do we use it? We use it when we want to do row exchanges. Okay, got it. So this is pretty much it. This is how the thing works. Okay. Now there's another one thing as well. Like there are laws which I wanna discuss as well. Very renowned laws, which is first law is AB is not equals to BA. Let me strike it out. Okay. And second one is AB bracket C is equals to A bracket BC. This is known as cumulative. No, the upper one is cumulative and the lower one is associative property. So these two properties you need to have in mind, that if I'm writing, like let's say here, let's say I'm writing E32 E21, and I'm multiplying with A, it will give me the same answer,
Mm.
right? So like it doesn't matter which you multiply, but if you change the order, then the answer will differ. You can't like multiply first E32 with A. First this two
Mm.
has to be done, and then this two, or else this two and this two. You can't like swap elements, swap matrices. Okay, these two laws you have to understand. Okay, so this is the thing.
Now
Again we
question
have,
OTP 623474.
okay. So in this lecture, we have talked about matrix multiplication, in that Gauss elimination. After that, we have talked about mathematical description of Gauss elimination.
912851.
Yeah. So we have talked about mathematical description of Gauss elimination. We have talked about permutation matrix, and we have talked about loss. 4 different things.